Inductive and deductive reasoning. Inductive reasoning is the process of arriving at a general conclusion based on observations of specific examples. Inductive reasoning goes from specific premises to general conclusion. An argument begins with the set of premises and is supported by conclusion. So there are some premises and then conclusion. The inductive reasoning goes from specific premises to the general conclusion. See the example of inductive argument or inductive reasoning. Here are some premises and there is a conclusion. So the premises is, the first premise is bluebird fly, hummingbirds fly, cardinals fly. So the conclusion is all birds fly. So these premises are specific examples, specific premises, and the conclusion is for general, that all birds fly. So when you go from specific things to general conclusion, specific premises to general conclusion, then this is called a inductive argument or inductive reasoning. Next example of inductive argument is 3 plus 4 is 7, 2 plus 3 is 5, 2 plus 3 is 5. So this is double written, so we can remove this. Okay, so the first premise is 3 plus 4 is 7. The second is 2 plus 3 is 5. And then the conclusion is sum of even and odd number is an odd number. So the premise, based on this premise, the conclusion is made, and this conclusion is the general conclusion. Okay, so specific examples to general conclusion. Now the deductive reasoning always goes from the general premises to a specific conclusion. And this is a process of proving a specific conclusion from one or more general statements. Okay, so the premise is all doctors are intelligent. This is just example, one example. And another premise is Dr. Smith is a doctor. So the conclusion is Dr. Smith is intelligent. So here from general conclusion, from general premises, like all doctors are intelligent and Dr. Smith is a doctor, the conclusion is Dr. Smith is intelligent. So from general to specific. If you go from specific to general, it is a inductive reasoning. And if you go from general to specific, like all doctors, and then the conclusion is for one doctor, Dr. Smith. Okay, so this is example of deductive reasoning. Another example is the premise is 2 times a number is always even. So this is for all general numbers. 2 times any number is even number. And another premise is 5 is a number, and the conclusion is 5 times 2 equals to 10 is an even number. So this goes from general premise to specific conclusion. So this type of reasoning is deductive reasoning. So if you go from general to specific. Okay, now how we use the inductive and deductive reasoning. Okay, using inductive reasoning, we use inductive reasoning to identify the pattern of a sequence, and we use this pattern to find next number. So this is one use of inductive reasoning. Okay, so we look at the pattern, and then this is a general, and then try to figure out what is the trend, and then find out the next number. Okay, so we can use the inductive reasoning to find out the next number. Okay, so from specific numbers, so 3, 12, 21, 30 and 39, these are the specific numbers. So using these numbers, we try to find a general trend in this sequence, and then use that to find out the next number. So this goes from specific to general. Identify a pattern in each list of the numbers, and then use these to find next number. So look at 3, 12, 21, 30, 39, right? And then find out the next number. Since the numbers here are increasing, right? So here 3 and then 12, 21, 30, 39. So the numbers are increasing. So it has to be some numbers to be added or multiplied, right? So try to find out the trend, how this is going on. So it goes from 3 to 12 and 21 and 30 and 39. So in each step, a number 9 is being added, right? So 3 plus 9 is 12, and 12 plus 9, 21, 21 plus 9, and then plus 9. So the next number has to be 39 plus 9, right? So 39 plus 9 is 48, right? So this is the answer. So this is an inductive reasoning, because we look at these specific numbers and then find a general trend of the sequence, and then you find out the next number. Second question is, identify a pattern in each list of numbers, and then use the pattern to find the next number again. So we have 3, 12, 48, 192 and 768. See, when the numbers are increasing, then either it is being added or multiplied, or there may be some other rules that we have to figure out. In this specific example, you need to multiply. See here, 3 times 4 is 12, and 12 times 4 is 48, and 48 times 4 is 192, and 192 times 4 is 768. So in each number, in each previous number, preceding number, we multiply by 4 to get the next number. So we can conclude that the next number here has to be the multiply or the product of 768 and 4. So multiply 768 times 4. So we get the next number is 4 times 768, 3072. Okay, so this is the next answer. Okay, now what number comes next to this list of number? Okay, as I said, sometimes we need to add, sometimes multiply, but there may be some other rule that we have to find out. Okay, so we need to find out if there is some other specific things going on. See, in this example, 1, 1, 2, 3, 5, 8, 13, 21. So what it does is the pattern is formed by adding the previous two numbers. See, when you add 1 and 1, you get 2. And you add 1 and 2, you get 3. You add 2 and 3 to get 5. 3 and 5, 8. 5 and 8, 13. 8 and 13, 21. So the pattern is, now you add the two numbers to get the next number, right? So the thing is, we need to add the two previous numbers. So the next number in here will be 13 plus 21, which is 34. So that is the next number, right? So here, see, here I did this. So here 1 and 1, 2, 2 and 1, 3, 3 and 2, 5, 5 and 8, 13, 8 and 13, 21, and 21 plus 13, is 34, which is the next number. So in getting conclusion in inductive reasoning is not only add or multiply. Sometimes we need to think some other things, what is going on with the sequence. So figuring out that idea is one use of inductive reasoning. Now sometimes the sequence or using inductive reasoning is based on some geometric diagram or some other objects. Like in this question, find out, describe two patterns in the sequence of figures. Okay, so we have a figure, we have a diagram, and we need to find out two patterns in the sequence. Now the first pattern is, look at this, this is a circle, this is a square, right? So again, circle and square. So what comes next? That is one thing. Like if it is a circle and a square and then circle and a square, the next has to be a circle, right? So that is one pattern that we need to figure out. So the solution is the circle. And the next is the dot. See here, the dot starts at here, and in the next diagram the dot goes one step forward. So from this step to this step, so from here to here, so this goes from this to this, so this goes from this to this, right? So it goes, the whole thing move one step one step back, right? So one step back, so it goes, so this goes there, this goes there, this goes there, so 1 2 3, and then again from this to this, this goes there, this goes there, this goes there, so we get 1 in here and 2 in here and 3 in here, right? So all these dots just moving one step, right? So this is now from this to this, right? So 1 goes there in here, see, and then 2, and then 3 goes there. So what is in the next one? So what we get in the next one? See, we have 1 in this place, so it has to go to there, right? So which is this, and then 2 goes there, 3 goes there. So one thing is a circle and the other are the dots, the position of the dots. So this is the answer in the next step. Okay, so this is how we use inductive reasoning to figure out the pattern, maybe in the number or maybe in some object or some diagram or some other things. So this type of idea to think based on the given specific examples from a given things, we look at the things and get idea to apply for the next, to find out the next item. So this is one way to get to use inductive reasoning. Okay, now the next is, like, say, when you work in math, we do steps, right? So if you do steps, like you add or you multiply, you subtract, we do several of those items in math. So when you solve math questions, you add sometimes, you do multiply sometimes you subtract. So what we are doing there is we are either doing inductive or we are doing the deductive steps, deductive process. Here it says do the following steps in question 5. Do the following steps: multiply by 5 and then add 3, and do this by using an inductive reasoning by choosing a number. So when you choose one specific number and do these steps, these are the inductive steps, because we are specific to a single number. But if you take a bunch of number, like if you work the whole thing for in general numbers, for all numbers, then this is for deductive. So I will come to that point. First, let's see for inductive reasoning, do these steps by using inductive reasoning, right? So for inductive reasoning, we choose a specific number. So let's choose a specific number, because inductive reasoning is from a specific number. Okay, so the specific, for a specific number, so let's choose the number be 4. This is just I choose 4. You can choose any other number, and we do these steps. So we choose number 4 and to do the steps above. So we do these steps. So first multiply by 5. So 5 times 4 is 20. And then add 3. 20 plus 3, 23. So by using inductive reasoning, the answer to these steps is 23. If you choose a number 4. If we choose another number, we get a different answer. Of course, we get a different answer, but we don't have here to do specific number. We are free to choose any number. We just need to do these steps using inductive reasoning. So inductive reasoning, using inductive reasoning, we choose a number, a specific number, and do the steps, do the work. Now we do the same thing, multiply by 5 and then add 3 using a deductive reasoning. And see, for deductive reasoning, we choose a general number. So because deductive reasoning, it comes from a general to specific, right? So general to specific. So we choose n as a general number. So here we choose 4 for a specific number, 4. You can choose 2, 3, 5, any number, okay? But for the deductive step, for the deductive reasoning, if you do these steps using deductive argument, using deductive reasoning, we choose a general number. We choose a number that represents any number that we generally use by n. Okay, so we choose n as a general number and do these steps. So multiply by 5 will be 5n, 5 times n, which is 5n, because we are not choosing a specific number now. We are choosing a n, right? We are choosing n, which represents the whole thing, whole number, everything. Okay, so 5n and then add 3 is 5n plus 3. So when you do this way, you do these steps using a general number, then this is a deductive way, deductive method to represent or to do these steps. So using deductive reasoning, the answer to these steps is 5n plus 3. Okay, so by using inductive and using a number 4, we got a number 23. But you do by deductive, we choose a number n to represent everything, and this is 5n plus 3. Okay, now solve the equation 2x plus 5 equals to 7 by using deductive reasoning. See, when you do deductive reasoning, the use of deductive reasoning is we do some work by using a previously approved rules. So if you use a rule which is already proved, use that rule and solve some problem, do steps, then that is a deductive method, deductive reasoning. In deductive reasoning, what we do is we use a rule which is already established rule. Okay, we use those rules to solve step by step and get into a specific answer. In inductive reasoning, what we did was like we saw a pattern and then figure out the next number, right? In deductive reasoning, we use the rules which are already proved, and using those rules, we get into a specific answer. So using rules is using a general trend, using a general premise, which was already proved, right? So using that item, using that thing, if you prove, something new and get a specific answer. That is deductive reasoning. Now here, when you solve these equations, we use deductive reasoning. We use deductive reasoning to solve equation. And how we use deductive reasoning? Because we use certain rules to solve these equations, right? To solve this equation. So what rules we apply? Say here we use this rule. Rule 1. We can subtract a number on both sides of an equation. So this is a rule which was established long time ago. That means this rule is for every equation. So this is for general equation, right? So we use this rule to break down the equation into a simpler equation, right? So we get 2x plus 5 equals to 7. This is the equation. Now subtract 5 on both sides, because we can subtract 5 on both sides of an equation. And this is not only for this equation. We can do this for any equation. Okay, so this is what we are doing, is we are applying a general rule to break down the equation. So we do subtract 5 and then you cancel 5. You can cancel 5 and so you get 2x equals to 2, right? So this is the first rule we apply. Now we use chain of rules. We can use as many rule we can. So rule 2 is, now we can divide by a number on both sides of an equation. So we can divide by the same number on both sides of an equation. So we divide by 2 to cancel 2. Okay, so we get 1. So what we get is x equals to 1, right? So using deductive reasoning, the solution to the equation is x equals to 1. So what we did, and how did we use the deductive reasoning in these steps? See, the deductive reasoning we used because we used a general premises. General premises means the general rules. We used the general rules and we got a conclusion, a specific number. So we got x equals to 1. This is a specific number. So these rules, we can apply these rules and get x equals to 1 answer. So using inductive reasoning is applying our technique to find certain pattern going on, what is going on in the sequence or something, by looking at some specific numbers. We looked at some specific numbers and then we figure out the general pattern, and we found a next number in the sequence which was a inductive reasoning. In the deductive reasoning, we use rules and then we solve step by step of the problem, of the question. Okay, and in the inductive reasoning we use a specific number. In deductive reasoning we use a general number n. So this is the main difference of inductive and deductive reasoning. Okay, I'll see you in the next video.